We learned from the previous video and from class, we've gone over that we're working with geometric sequences now, which are patterns that are formed by multiplying or dividing every time by a number called the common ratio. We are going to write equations for this today using recursive equations. And I want you to make a note. This was covered in the video, but we're going to write these as multiplication. So sometimes our brains see a division a little bit quicker, and we'll see a couple examples of that today, but we do want to remember we're going to write everything as multiplication, so definitely write that on your paper. When we talk about the recursive form for a geometric sequence, it looks almost exactly like the ones we did for arithmetic. I'm going to give you the OK option and probably the one that's more common or preferred. So the OK option, that's not wrong, just a little less common to see, is still going to be the next equals the previous number, and then times your common ratio, which we represent with that little lowercase r. And we do still have to say what the start number is. And your start number is going to be whatever your first term is. So again, just like last time, you can kind of use those as sentence frames. Put in the ratio, put in the first term, and you've got your equation. The more common way to write this one, I'm going to call it the preferred way, is going to look like this. We still write the next equals, but then the number we're multiplying actually goes in front, times the previous. And then the start number looks exactly the same. So still start at the first term. And the reason this is more common, so think about when we have something like 2x, we put the 2 in front. We don't as often see that as x times 2. Same idea here. We're going to put the number in front of the word. Again, both are correct, but you're probably going to see that preferred method more often. The other thing I wanted to remind you of in case you forgot is how we can find the ratio. Sometimes they're very obvious, sometimes they're not quite as obvious. So I'll put a note up at the top to find the ratio. We can always do the second number. That's a number sign, but it doesn't look like it. The second number divided by the first number, or the first term. And that will help us to find our ratio, and we can verify it for the next one. So these patterns we are doing exclusively geometric, so we know the patterns are going to be multiplying or dividing. But do be careful if you were to see problems that were arithmetic and geometric jumbled, you would have to pay a little bit more attention to detail. So for our first examples, we just want to write the recursive form for each sequence, which means we need to start by picking out the ratio. So in this first example, when I look at that pattern, if you're anything like me, I see 32, 16, 8, 4, 2. My mind goes to division. I see it's dividing by 2. But we did say we're going to write all of these as multiplication. And so we can figure out what it is you're multiplying by. To find the ratio, we can do the second number divided by the first number, 16 over 32. And you are welcome to use a calculator if the decimal works out nicely. A lot of times we will see fractions with these though, so we'll do this one as a fraction. 16 over 32 simplifies to 1/2. So multiplying by 1/2 is the same as dividing by 2. And then of course our start number is going to be 32. So when we write this one up, we would write next equals 1/2 times the previous number, and we start at 32. So again, that's written specifically with multiplication, and it wouldn't be wrong to say previous divided by 2, but when we move to kind of the next level of equations, you're going to want to have focused on multiplication here. So in number two looks like it's going to be tricky because I have some fraction stuff going on, but it's really not so bad. So for this one, again, we need to find the ratio, and we can do that by doing the second number divided by the first number. And if you remember, I believe we reviewed this in the previous video, when we divide fractions, we flip the second one. So in this case, that's 4 So when we flip 4 over 1, it's 1/4, and we multiply is how we can do this by hand. You are welcome to use a calculator. This just seems like a great opportunity to review how to divide fractions. So then when I multiply straight across the top. I get 8 over 12. And we need to simplify that. Both of those numbers are divisible by 4. That simplifies to 2/3. So now if you did this on a calculator, actually, it would give you 0.6 repeating. And if you round that number, your pattern actually won't work out correctly the whole way. And so if you're using a calculator and you get a decimal that does not end nicely, you would definitely want to use the fraction version so that your pattern is as precise as possible. So when we write this, we say next equals, this is 2/3 times the previous number. And just like when we write like 2x, again, for example, we don't put the time symbol in between. You actually don't need the time symbol there, but I tend to write it. And then we say start, and this one started at 4. All right, so I would encourage you here to pause. If you think you've got the hang of this, pause, try number 3 and 4, and then turn it back on when you're ready to check your work. Number 3 may just jump out at you what it was doing here, but just in case, we can always do the second number divided by the first. So 12 divided by 3 is 4. So that tells me my pattern is multiplying by 4 every time. And so I can also pick out my first number, which is 3. So we would write next equals 4 times the previous number, and we started at 3. And then last one of these, again, start with your ratio. So 80 divided by 100. And this one actually does work out nicely if you want to use a decimal, so we can do one example with a decimal. That decimal would be 0.8. So we also pick out our start number, which is 100 here. Next equals 0.8 times the previous, and we started at 100. If you did this one, if you tried it on your own and wrote it as a fraction, the simplified version would be 4/5. So if you had 4/5 as your ratio, that would be just fine too. So now let's check it out in the context of some word problems. Same idea though. It says Raul has a retirement account set up to support him and his family after he retires. The following sequence represents the balance in his account after his annual withdrawals. So we can see those numbers are decreasing. We're taking money out of our account. Pretty quickly, we can identify the starting number right here. He started with $500,000. And to find the ratio, just like before, I'm going to do the second number, 475,000, divided by the first number, 500,000. And that means, I'm going to use my calculator to do this one, 475,000 divided by 500,000 is 0.95. And again, I'm going to use the decimal since that one does, I don't have to round it. It stays exact. And so now we can write our equation. Next equals 0.95 times the previous number. And we started at 500,000. If you feel good about that one, go ahead and pause. Try number 6 on your own. Number 6 says, suppose a singer gets paid every time her song is used in a commercial. The following sequence gives the amount she was paid the last 4 months. So this time my numbers are increasing. I can see she's getting paid more each month, starting at 1,000. So to find the ratio, I'm going to do the second number divided by the first number. So 1,050 divided by 1,000. Again, use your calculator if you need to. Gives us 1.05. And again, I did not have to round that one. That's exactly what it came out to, so I feel good about using that as a decimal. So to get to the next number, we multiply by 1.05 times the previous number. And we started at 1,000. All right, last two examples for you. We are given the equations and we actually want to write the pattern this time. So, or write out the sequence based on the information we're given. So these ones do have that multiplication at the end, but I can still pick out the pattern quickly. We start at 4 and we multiply by 3 every time. So my first number is 4. Remember, when it gives you the start number, that's where you start. You don't have to skip to the next one. We want the first 4 terms, so 4 times 3 is 12. Times 3 is 36. 36 times 3 is 108. So again, my start number came from right here, and then we multiplied by 3 every time. So go ahead and try the next one if you want to. Take a pause if you think you've got it. This one we should be multiplying by 1/2, and we start at 56. So again, quick math for you. Multiplying by 1/2 is the same as dividing by 2, which might make that easier to think about in your head. My next number would be 28, or I can multiply by 0.5, and then 14, and then 7. So start number came directly from our equation, and then we multiplied by 1/2 every time. One thing worth mentioning, or maybe reminding you from the last video, when we are multiplying by something bigger than 1, our numbers are increasing. So if you check out, like in example 3, we were multiplying by 4. Our ratio was 4, which is bigger than 1, and our numbers were getting bigger. In the number 6, when we were multiplying by 1.05, bigger than 1, our numbers got bigger. When we were multiplying by 3 in number 7, our numbers were increasing as well. When we multiply by a fraction that is smaller than 1, so all the other examples like 1/2, 2/3, 0.8, 0.95, or another 1/2, our numbers are going to decrease. So when r is greater than 1, we are increasing, and when it's lower than 1, we are decreasing.